Verify 1 plus secant x over secant x is sine square x over 1 minus cos x. Now it's better to convert everything to sines and cosines. So let's start on the left side. Left side is a fraction where the numerator is 1 plus secant x and the denominator is secant x. Now what I'm trying to do is I'm trying to convert secant x, write that as 1 over cosine x. So our numerator is going to get a little bit complicated. Now the first part is just 1 plus, but instead of secant x, I'm going to write 1 over cos x. And the denominator will also become a fraction, which is 1 over cos x. So I have this complicated fraction where I'm going to have a big line to talk about the numerator. Now notice I have to add 1 plus this fraction. Now how do I add two fractions? Well, 1 is not a fraction, but I can always think of that as 1 over 1. And here is what I suggest. Adding or subtracting fractions is easy if you follow this process. To get the numerator, you simply cross multiply. So a over b plus c over d is AD plus BC. That's your numerator. And your denominator is the product of the denominators, b and d. So if you want to add 1 over 1 plus 1 over cosine x, you're going to have a numerator of 1 times cos, which is cos, plus 1 times 1, that's a 1, over 1 times cos is just cos. And your denominator is 1 over cos x. So you have a complicated fraction where the numerator is a fraction and the denominator is a fraction. So we are dividing one fraction by another. And we learned in algebra that if you want to divide a fraction by another, what you do is you keep the numerator the same over cos x and you flip the second fraction, the denominator fraction, because dividing by something is the same as multiplying by its reciprocal. That's the idea. And notice what we have is now cos x plus 1 times cos x over cos x times 1. Now, does it look like the right side? No, not yet. So what can I do? Now, notice that to multiply two fractions, you simply multiply them across. So you want to see your numerator as a product of this binomial. So if it has two terms, I'm going to put them in parentheses, times cos x, and the denominator is cos x times 1. So there is a common factor of cos x in the numerator and denominator. We can get rid of that. So what I have is cos x plus 1 over 1, which is simply cos x plus 1. Now, does it look like the right side? Again, no. So what I'm going to do is, but this looks much simpler, I will try to get the right side also equal to this. So in fact, let's go ahead and work on this side of the paper and say that the right side is sine square x over 1 minus cos x. Now I want to recall one identity, one Pythagorean identity. Sine square x plus cos square x is equal to 1. This is one identity that you definitely want to remember. So you can rewrite your right side as numerator. Sine square x is same as 1 minus cos square x. And then the denominator, we can copy it. And notice, there's one other formula from algebra that we want to remember. If you multiply a minus b times a plus b, you get a square minus b square. Now going in the reverse direction, you can always factor a difference of squares. So if you see something like a square minus b square, you can factor it into a minus b and a plus b. And notice, this is actually a difference of squares because 1 is 1 square. So I can rewrite my numerator. Let me copy the denominator. It's just 1 minus cos x. And the numerator could be factored into 1 minus cos x and 1 plus cos x. And the denominator, you can put that binomial in parentheses. Now notice there is a common factor of 1 minus cos x in both numerator and denominator. So you can strike that out. So what's left is simply 1 plus cos x. So notice that's what we had for the left side, cos x plus 1, which means we just proved that the left is equal to right. So at this point we are done.